For this video, let's solve for the integral of f of z, which is equal to z along a straight line from 0 to 2 plus I. Here, we're going to use the formula for finding the complex integral of f of z along a certain path. It's identified as, we have here the integral of f of z dz along the certain path c is equivalent to f of z of t times z prime of t dt from A to B. Okay? Whatever be the result of this, automatically that's the result of the given expression as well. In order for us to do this, we need to use the parameterization of our path along straight line. If you can still remember, the parameterization of our straight line is actually identified in this given z of t function. You have z of t is equal to, you will have z sub 1 plus t times the difference of z sub 2 and z sub 1. This is the parameterization of the path for a straight line. Now, given our situation here, our z sub 1 is actually 0, the starting point, and our z sub 2 is actually 2 plus I. We can now solve for z of t, which we need here, to substitute on our given function, and of course identify this as well. So allow me to start solving for this in the meantime before returning to the equation or the integration at hand. So we have here our z of t is actually z sub 1 0 plus t times 2 plus I minus 0. That's z sub 2 minus z sub 1, which gives us the result, which is equal to 2 plus I of t. This is our z of t. Now, just to continue, we can now solve for the z prime of t. With respect to t here, we will be treating this as one expression. This one here. This will be its constant with respect to t. That would mean its derivative with respect to t is simply 2 plus I itself. We now have our z prime of t. Our z of t earlier, which is this one here, is not necessarily the expression we need here. It depends on our given function. Since our function of z is just z itself, so basically, we have f of z of t is just equivalent to z of t itself. Okay? By, of course, substitution. Meaning f of z of t is just equivalent to the same expression here, 2 plus I of t. Take note, it's not all the time that this is true. It depends on our given function here, because if this is z squared, so we're going to square this, and we're going to square this as well. It depends on what would be our function, but since earlier it was f of z equal to z, so we have the same expression here. Now, both of them are already given. Let us now proceed again to the integration, of our f of z dz along the path, straight line from 0 to 2i, is equivalent to, you have f of z of t times z prime of t dt from A to B. So our given expression here was this one, 2 plus I of t, 2 plus I t. Then we have this one here, times 2 plus I dt from A to B. The question now is, what would be our A and what would be our B? As mentioned in a video on parameterization along a straight line, we can of course invoke the value of our A, the starting point, and our B, which is our endpoint, as 0 and 1 respectively. We can now use that our T, which is originally A and B, is actually between 0 and 1. As discussed previously, you can use other regions as well. But this is for convenience because it's the simplest, what they call this one, interval for your t along a straight line. So you have here 0 to 1. What we need to do here is simply solve for this Now, take note we are on integration. We need to use all the necessary properties of integrals and techniques in order for us to identify the integral. One thing that we could do here is actually on the constant multiple. Since this is with respect to t, all the other things without t can be combined and moved outside. Okay, that's the constant multiple as also discussed previously. We actually have here 0, 1. We have 2 of this. That's actually 2 plus I squared t dt. Since this doesn't have any t, we can treat that as a constant, moving that outside. You have here 0 to 1 of t dt only. Okay, so that would be the next process here, which would allow us this. Of course, if you would like to start by squaring this expression, it's actually equivalent to 2 plus I times 2 plus I using FOIL method. 4, you have here plus 2I, and of course plus I squared. We know that I squared is equal to negative 1, so you have here 4 plus 4I minus 1, which gives us 3 plus 4I. This is the value of this one here, 3 plus 4I times the integral of this. The integral of t dt is actually equivalent to t squared over 2, right? From 0 to 1. So we are going to use that here. We will have 3 plus 4I times, when we use 1 squared all over 2, or let's just simply say here over 2, minus 3 plus 4I, then you have here 0 squared over 2, which gives us this entire expression as 0. The remaining term here will only be 3 plus 4I times 1 half, or simplifying that, you will have here 3 halves plus 4 over 2, that's 2I. This is the integral of the given function f of z equal to z along a straight line from 0 to 2 plus I rather, using the parameterization for a straight line, at the same time all the necessary steps here to get the identified integral. This is the final answer for this item. Thank you very much for watching.